Hello, 5th and 6th grade. We are on the first lesson of science, which is 11.1 and 11.2, as we begin to discuss violent motions on Earth. So we are on page 128, if you'd like to open there, and we're going to read together. So, page 128, violent motions. Sometimes the temperature in a home becomes too warm or too cool. If the home has a thermostat, its function is to regulate the air inside the home to stay within a certain temperature range. Often, the temperature is not exactly what the dial or display reads, but it's within a comfortable range close to that setting. In a similar way, the Earth operates within a certain range that allows life to exist. The Earth is a planet designed for motion and balance. It's constantly moving towards a state of equilibrium. Motion does not stop once equilibrium is achieved, but it is balanced within a specific range. This concept includes all areas on and in the earth, including the air and water, as well as the movement of the lithospheric plates. As forces act on the earth, they continually cycle between imbalance and equilibrium. Simply because forces are equal does not mean that they are non existent. And so, forces, equilibrium means there's an equal or equality between all of the motion, which means things are generally at peace. But that doesn't always happen. The earth is always striving for equilibrium. But there is times when there is not an equilibrium, when plates are shifting in opposite relationship. And so that's when we see some of these violent motions happening on earth. Key ideas for this chapter. Forces on Earth cycle between imbalance and equilibrium. The Earth's constant motion directly affects its surface and its atmosphere. Severe weather and major surface events are often the result of the Earth moving towards a state of balance. All right, going over onto the other page. In living and non-living things alike, a state of balance or equilibrium occurs everywhere on Earth. Without it, life could not exist. This concept reflects God's character and glory. And the outlook. While weather patterns may change as Earth adjusts to a state of balance, God has promised that never again would He destroy all living things by a flood. He gave the rainbow as a sign of His covenant. When we are concerned about what is happening around us, we can remember the rainbow and trust His promise that as long as the earth endures, seed time and harvest will never cease. We trust that God will take care of us just as He does the earth. All right. Strange but true. What four main environmental clues indicate a tornado? We'll have to see that as we move on. We're going to go to the next page and start on earthquakes. We talked a little bit about this the other day with plate tectonics, how you have plates diverging and converging and transforming against each other. And these movements cause earthquakes. So we're on page 130 and we're going to read about earthquakes. Some vocabulary that we're going to touch on in this chapter. Focus. The focus is the point beneath the Earth's surface where rock moves, which causes an earthquake. Epicenter, the point on the Earth's surface directly above the focus. P wave, a type of seismic wave that travels through the Earth's interior and compresses and expands. And S waves, a type of seismic wave that travels through the Earth's interior and moves side to side, as well as up and down. Kind of like those ripple effects that we were talking about the other day. When you drop a rock in the water, it causes a ripple effect to happen. And that's what happens with seismic waves. Let's begin. One example of equilibrium being restored on Earth as a result of opposing unbalanced forces is an earthquake. The motion of an earthquake is actually very similar to the action of a stretched rubber band. When two lithospheric plates are forced in different directions, it produces stress in the rock and potential energy builds. The rock can only stretch so far before breaking. When it breaks, the plates snap back in an elastic motion, relieving the pressure that has built up. What is felt when an earthquake occurs is the elastic rebound of the plates. The energy that is released travels as seismic waves through the Earth's interior and along its surfaces. Most earthquakes actually begin underground. The location under the Earth's surface where the movement occurs is called the focus. Directly above the focus on the Earth's surface is the epicenter. The seismic waves carry energy and travel from the focus in all directions. The seismic waves that move out from the focus throughout the Earth's interior are called body waves. There are two types of body waves, P waves and S waves. When these waves reach the epicenter of the Earth's surface, they are called surface waves. P waves, also known as primary waves, think of first, primary. P waves, also known as primary waves, move the fastest. They are the first to be detected and can travel through solid, liquid, and gases. P waves compress and expand as they spread outward from the focus, causing rock particles to squeeze and stretch. S waves are also called secondary waves because they are the second fastest waves. They shake the ground back and forth, causing the rock to stretch and change shape in a sideways direction. Unlike P waves, S waves cannot travel through liquids. While P waves can damage buildings, it is S waves that shake structures violently. When P and S waves reach the surface, they become surface waves. Even though the surface waves are the slowest, they can produce severe ground movement and are the most destructive type of waves. Seismologists measure the Earth's earthquakes with different types of scales. The Mercalli scale rates an earthquake level of damage from 1 to 12. The Richter scale measures the strength or magnitude of an earthquake on a scale that ranges from 1 to 10. The movement magnitude scale estimates the total energy released by an earthquake, also on a scale from 1 to 10. So when we see earthquakes and you see videos of earthquakes, or if you've ever experienced an earthquake, the P waves are actually happening underground. And so you don't actually feel or see that. It can cause destruction. But the secondary waves, that second burst of energy, is what shakes the earth and what causes buildings to crumble and roads to fall apart and landslides to happen. And depending on the magnitude of the earthquake can determine the magnitude of the damage caused by the earthquake. You have a few pictures on the bottom of your pages. On page 130, it says, when rock moves deep within the crust, energy travels in the waves to the surface and an earthquake results. So you can see that focus point is far below the surface of the earth. And when it happens there, you have the body waves that move out like those ripples. They move out in all directions, not just to the surface, but sideways as well. Okay? The epicenter is the point on the surface that is straight above the focus. So it's where it's affected the surface of the earth. And then you have surface waves from that, the secondary waves, and they are what cause the shaking and the movement on the surface. On page 131, you have a few other pictures. So P waves, direction of the waves, they go side to side, so they're moving out from that focus. And you can see it does cause some destruction on the surface, not because of shaking, but because of the sheer energy. So you have railroad tracks can break apart. S waves, the secondary waves, move in one direction and they cause the earth to shake. Surface waves, you have a cyclical energy underneath the surface, and then you have it moving in opposite directions. And it says once P and S waves reach the Earth's surface, they become known as surface waves and will have a combination of P wave and S wave movements. And so we can't really estimate what's going to happen from an earthquake, the destruction that the waves are going to cause, because they're different every time. In the field, architects and engineers are required to be familiar with government-issued building codes. These codes specify how buildings must be constructed. They are in place as an effort to ensure the safety and health of all who will be in the buildings. Areas with significant earthquake activity makes these codes even more important. The structure and the construction materials must be strong, yet elastic to withstand the stretch and shaking forces of an earthquake. Rubber and steel devices known as laminated rubber bearings not only support a building's weight, but allow its foundation to move with the ground. Buildings like these in Japan were designed with rubber bearings and other specialized equipment to minimize damage when an earthquake occurs. I encourage you with parent guidance to look up some videos of earthquakes. YouTube has a lot, but especially bridges. It's really fascinating to see what happens with bridges, especially suspension bridges during an earthquake. You can see massive bridges looking like they're just a wave from the surface waves just pushing that energy through. And sometimes they have minimal damage because they have a level of elasticity to them, because they're built with materials that have a little bit of give to them so that they're not just going to crumble at the first shock wave. Same thing with skyscrapers and tall buildings. Even with winds, skyscrapers do have a little margin of movement. They're not perfectly rigid. So if an earthquake occurs, as those shock waves of energy go through, they are allowed some form of movement without completely crumbling and breaking. So take a moment to see if you can look up some interesting videos. National Geographic, go to some reputable websites or reputable videos on YouTube to show some of the destruction from earthquakes, especially bridges. It's really fascinating. All right. So in your lab books yesterday or the other day, we had done the page on plate movement, and we talked about transform reaction, we talked about converging reaction, and we talked about diverging reaction. And because of that plate movement, because of those tectonic plates shifting and moving and looking for equilibrium on the surface of the earth, as we said, when things happen at one spot, something else is happening on the other end of that plate. And so that's when you see some of these violent motions taking place, earthquakes being one of them. So for the rest of today, take some time. If you have books on earthquakes, if you want to read more on earthquakes, if you have encyclopedias, or go online. Look at videos of earthquakes with your parents' permission and guidance. Look up National Geographic for kids, information about earthquakes, and do some research because it's really fascinating. I'll see you next time.